Before getting going with crafting videos, I wanted to make sure I had a decent lighting setup. There was an old all-in-one PC lying around, so I figured I'd try to commandeer the backlight from it and set it up as a positionable light panel. There are some great videos about using screen backlights that I learned from and will be linked to in the description below. Here's a pro tip before we get started. Maybe don't record a whole 6 hours of footage of dinking around, working on the project, so there doesn't end up being a ton of clips to scrub through and edit down into something coherent. Getting the screen apart just required some dis-screwing of the computer bits from the screen and some prying off of the clipped-on bezel frame. Through some form of science, the whole screen is evenly illuminated from LEDs on just one side of the panel. Probably something to do with all of the unnecessary layers of plastics here. The only component needed besides the panel itself is the controller board that powers it. I ran into some difficulties trying to find a data sheet or diagram providing instructions on what electrics should be electricking where. Finally, a PDF of a similar computer's circuit layout gave me a place to start. I guess one positive thing that can come from leaving the camera recording the whole time is providing insight into just how long it takes to do anything. A simple search for some info can be a whole thing in itself that takes an, oh, I'll just pop this thing together real quick, to an, oh, here I am scrolling through boring diagrams just to get info on something that I could have just figured out by rehooking the screen up and powering on the computer and probing each wire to see what voltages were on them, but oh wait, I can't power the computer on now because I screwed around with its power connector during the process of diswiring the PCB that I'm now stuck scrolling the internet for schematics about. You know, that whole ploy. Turns out pins 1, 2, 3, and 4 are ground. Pins 9, 10, 11, and 12 are supply voltage. Pin 5 is LCD_BKOFF. And pin 7 is LCD_PWM. LCD_BKOFF might mean, hi, I'm the signal that declares that the backlight should be off. So if I am indicating a logical true or a digital thumbs up, then the screen should be off. I'm saying yes to being off. But there can also be a case for the name of a signal indicating its own behavior, as in, I'm the demonstrator of what off means. So when I'm off, or a logical false, then the screen should also be off, false, dark, or de-energized. So in the case of this signal, it is behaving like an enable input, but its name doesn't include the word enable. It includes the word off, which might make full sense to people in the circuit world. I don't know, hit me up. Anyway, if pin 5 indicates it should be on, then pin 7 indicates how much on it should be. Probably it can take a pulse width modulation signal and follow its duty cycle to get the percentage of brightness the panel should be outputting. I'm just going to send it a solid DC voltage to say go full bright like a... The power supply voltage for the PC that this screen came from is 19 volts. And it looks like that is what the voltage on pins 9, 10, 11, and 12 can accept. From my experience, signals like enable or pulse width modulation don't go up higher than 5 volts because they are only intended for conveying information and not actually powering anything. I didn't want to put too high a voltage on pins 5 and 7 and fry anything, and since I want to always run this light as on and at full brightness, that means that there will always be true or 5 volts on pins 5 and 7. And since pins 9, 10, 11, and 12 will accept a voltage of up to 19 volts. That means that they are also fine with accepting a lower voltage. So I chose the simple, lazy way and just wired pins 5, 7, 9, 10, 11, and 12 all together at 5 volts. That way I could just plug the thing in and it gets lit. Heyo, illumination. Now comes the building of the frame. The plan was to start with a piece of plywood 1 inch more wide and 1 inch more tall than the light panel. That would leave half an inch of the plywood available to attach a mitered wood bezel to act as an enclosure. After getting the plywood sized up, the next step was cutting a rabbet that would be able to be cut at 45-degree angles and used as the bezel frame. Please consider the following as a demonstration of how to turn a simple task into a terrible, horrible experience using only stubbornness and foolishness. This piece of poplar was twisted, and not a good candidate for rabbeting on the table saw, which is exactly why I used it anyway. Cutting the groove the way I did left an uneven surface that could have been smoothed easily by flipping the piece end over end and correcting it on the table saw. So, naturally, I grabbed a chisel and further added to the unevenness. Next, I cut the pieces of the frame at 45-degree angles, but a bit lengthier than their final sizes so I could sneak up on the right fit later. Before finalizing and attaching the bezel, I measured out a spot for the electronics and hogged out an opening for them to reside in. As a show of solidarity to my other bad moves, I made that opening just shallow enough that the electronics would not fully sit below the plane of the opening. Good work. Once I made it to attaching the bezel to the piece of plywood, I more fully appreciated the result of my poor life choices and finally ripped each piece on the table saw to smooth out and evenify the surfaces, just as I should have done all those times ago. One final slot was cut in the piece of plywood to accommodate a lip on the back of the frame of the light panel. The frame pieces were glue, nailed, and screwed on the top, left, and bottom. The right piece was only screwed so it would be removable for sliding the light panel in and out. This concludes the construction of the frame assembly, clocking in at only 2 or 3 hours longer than it should have taken. As a chronic project starter and not finisher, I rarely actually benefit from having an unfinished project lying around, but alas, the time has come. I built a boom arm type stand to be used for a tablet, but it was way too wobbly, but ended up being perfect for holding up a light. After some quick retrofitting and figuring out how to squarely mount something on unsquare mounts, the light panel grew legs. Now I'll be able to have a nice, even, and white light source that's easy on the eyes and great for shooting video. It provides plenty of light even on its own and does a good job at knocking down harsh shadows because the source of the light is spread out evenly over the panel. I'm pretty happy with how this turned out, and I will for sure be on the lookout in the future for some more light panels to add to this collection.